Welcome back. Now we're going to continue on with doing our clustering algorithm. So you can see here in this data set that I have, I told you before I had decided which attributes I was going to create dummies for, so I've done that here. I know that you've done that in other homework assignments, so I didn't take you through those steps. I'm assuming that you know how to get to that. You just need to go under transform, transform canonical data, create dummies, and then just choose the attributes. It creates this new spreadsheet called create dummies. So from here to start the clustering, I'm going to click on cluster. K means clustering, and it's going to bring up a dialog box. Now mine's preloaded because I already went through this step already. So in this case, you would need to go through and manually bring over the attributes that you want to include. If you want to make it easy, just create a data set where you only have the variables that you're actually going to include, and that way you don't have to you can just pull everything over at the same time. As I went through this though, just so you're aware again of how I think through this process, so I'm doing data mining, I didn't include everything that I thought I was going to include. As I thought about some things, for instance, under age, I ended up just going with the age groups instead of including age, mainly because I was just getting so many attributes in here. I was trying to decrease some. And then I included most of everything else, but I think under grades, instead of doing all the grades, I just included the grade group. So I have those students who received an A or a C in a particular course, D to F, I, S, or Y, which are special grades that have different meanings, and then W for withdrawal. I only included the delivery method of internet because right now I'm interested in how virtual students are performing in their classes. And then I included everything else that we talked about, including the developmental indicators that are listed here. I clicked next. I started with, I left everything to its default. So I left 2 clusters, 10 iterations. It needs a starting point for when it does the Euclidean distance, so I just left that as is. I did a fixed start, and then I clicked next. And again, I just left the options here. Show data summary as checked. Show distances from each cluster center as checked, and then clicked finish. It'll give you 2 sheets. Now I've done this twice, so I have one called KMC Output 1, but I also have my original run over here, which is the same. So if I go over to this KMC output and scroll down, you'll see it gives you some basic generic information about the worksheet that I used, the Create Dummies worksheet, the range, the number of records. And then I went down here to, I have 64 variables, which is actually quite a lot. And this is where the analysis comes in. So in cluster centers, here you can see we're getting averages for each of the clusters. So each of the clusters are being described in terms of all these 64 different variables. So if we want to look, just the idea to analyze this is you get these clusters, but you don't know what they mean. The way that you discern what they mean is by looking at this particular table. So in this case, I can see under age, both 27 years old. So they're 2 groups of approximately 27-year-old, at least the average age in that group. So there's really no differentiation in age. Now when we get to term GPA, we have 3.33 for the cluster 1, 2.5. So now we're seeing that there's some differences there. This first group is higher performing in terms of their grades, definitely higher performing in terms of their cumulative GPA. So they have a 3.66 in cluster 1, 2.8 in cluster 2. Total credits is approximately the same, 10 and 9 in the other. Sorry, I lost my spot. Let me get back up here. Okay. And then under credit hours, again, about the same. If I go over here to, this is interesting. So under gender female, because remember I created dummy variables, cluster 1 is primarily, it's all female. Cluster 2 is mostly female. It's about 69% female, 31% male. And then another interesting fact here is under ethnicity, this is saying that they are race, ethnicity, non-resident alien. So it means they're foreign students. So 66% of these students in cluster 1 are foreign students. And then 33% are under white. So they're either white or they're foreign. And then under here we can see there is a complete difference in terms of race and ethnicity as far as the categories. So it was differentiating quite a bit on that in these two groups. If I go over more, there's more things that we can look at. We can see here, here's another disparity. This first group is mostly, it's 67% part-time. I'm sorry, full-time. And in the second group, they're 38% full-time. So the first group is primarily a full-time group of students. Placement is showing different things too. This second one, they placed better in terms of they were placing more at college level. The second group is placing at developmental in various areas. So again, I can go through this and look, and you can also see the campus representation. The first group is primarily Harrisburg and virtual, and the other group is kind of spread out. There's 15% Harrisburg, 3% Gettysburg, International, Lancaster, Lebanon, and virtual is 64%. That's pretty high in New York. So as I go through this, I could actually probably see where if something is not making a difference in terms of it's not differentiating between the two groups, I could remove it and know that that's not really probably a good variable to look at in terms of clustering. The other thing we can notice, we did two groups here. I could go back and I could do more groups and see, go to 3, go to 4, and see how does it differentiate those groups. And then again, the last part of it is looking at each group, each cluster, determining how do you define that group and what does it mean. This is sometimes could be a precursor to other things. So say we have this extremely large data set that's very heterogeneous and we're trying to come up with groups that we can study. So this first group in here is basically female international students, and mostly international students, some white students, approximately 27 years old, high performing in terms of their GPA, generally speaking full-time. The cluster 2 is a little bit different. So maybe I would extract out those two groups and I could do classification and try to predict success in those two groups because there may be different factors for those two groups that lead to success in their courses. For instance, the one thing that jumped out at me was the full-time status. We know from research that students who attend full-time tend to do better in school. It makes sense. They're working less. They're focusing more on their studies. Whereas students who are part-time are generally speaking working at full-time or multiple jobs and have trouble focusing on their studies because of all the different things that they have going on in their life. So I wanted to show you kind of how to get through this whole process and how to analyze it. This hopefully should help you with your project as you start thinking about things. Where you go from there, there's not a clear plan. In this case, I probably would go back and do more clusters. I might take some of those clusters and look at them myself. I might take out some variables. And given I have 64 variables, I probably would do some kind of transformation using PCA to decrease the number of variables that hopefully help the results become more telling in terms of the analysis. So there's all different steps that you take. You can start with clustering, you can start with classification, then do clustering. It's really kind of up to you in your projects how you want to do this. But I wanted to show you how this would work in a real live data set and all the problems I experienced in terms of missing data and creating dummy variables, and some variables had too many distinct values and I couldn't include them. So understanding how to work through all of those issues that pop up as you're doing your data mining. I hope this helps you with the homework this week and with your project. And if you have any questions, of course, feel free to post on the discussion board or email me or call if you need to. I'd be happy to help you with any questions you may have. Good luck this week with your homework and your project.